Right. So a little bit of some ground rules. So the first thing is just keep in mind that I am a journalist, not a scientist. And so if you have questions for me that are asking for my opinion about something in space and astronomy, I cannot provide any additional information. I am able to accurately, I hope, convey the scientific consensus, but I am not able to then give you some kind of expert opinion or some kind of weighing one way or the other about what is the correct answer or any of that, right? Just a journalist, not a scientist. I've not gone and got my PhD in astronomy. I've only interviewed thousands of people, reported for 26 years, written thousands of stories, but I am always just attempting to synthesize and communicate what people are discovering. I think a lot of people have a problem with that. A lot of people get mad at me because I'm not willing to weigh in on their sort of favorite theory about something. Like, I don't know, the endless universe or UAPs or anything. And I think it's dangerous. Like, I really think it's dangerous for lay people to hold an opinion that is essentially has been arrived at either because you found somebody who is also a layperson very compelling in the way they made an argument, or that it just feels right? Like the whole point of the scientific method, the whole reason we have double-blind studies, the whole reason why we don't just go with our gut is that our gut is often wrong. And that the only way we make progress is when we stick to the scientific method, that we perform an experiment, we listen to what nature is actually telling us, and then we use that as a way to guide our understanding of various principles and the way things work. It's only when we do that does humanity's overall knowledge about the universe continue forward. And we have plenty of times, plenty of examples we can look back at when people just went with their gut, right? And got stuck for long times, right? That volcanoes are caused by the sky god and so on and so forth. And so that instinct in us to like listen to some charismatic person speaking on a YouTube video about something that they feel is true, that resonates with the part of our brain that's designed to listen to that. And so we have to really resist that. And so I'm hoping that when you see me do this, when I just go like, what does, the people who have studied this topic for their entire working life, who are ideally following the principles of the scientific method, either, double-blind studies, going for certain amounts of uncertainty, peer review, all of this, it's designed to weed out the bad ideas, to weed out the places where people haven't done appropriate homework, and that you're going to have large numbers of people that are agreeing on this one thing together, then that you can use as a guide for you to try and understand some phenomena in the universe. And without doing that, you are into dangerous waters. And that I think a lot of the issues that we have right now is that on the internet, on TikTok, on whatever, people can just say whatever they want. And if they say it well enough, then we believe them. Then we go, yeah, that's right. And then what turns into people believing a thing, turns into people voting for a thing, turns into policies, turns into bad science actually starting to harm people. And so, like, it's very low stakes. Like, where did the universe come from, right? Very low stakes when we're having those kinds of conversations. But people arriving to scientific conclusions the wrong way has real consequences in our daily lives. And we're seeing that more and more today with all of the controversy around things like vaccines, around climate change, that these are having real effects because people are coming to a scientific conclusion, they're voting their beliefs, and yet they didn't arrive at that conclusion through a long scientific process. So, that was part one. Anyway, sometimes I rant. So the second thing is that, I might know the answer. So, I'm going to ask for your questions, and I really give emphasis to the people who have never had a question answered before. So this is your first time. I'm really going to try. Like I see your name. I see you've never had a question answered before. I really want this to be your day. But if it's the same question we've had 1,000 times before, I know my audience is going to roll their eyes and go, oh, this one again? And so I may avoid the question, or I may not know the answer. However, we're going to try adding a new thing to the way we do the question shows, which is that if it's a great question, but I don't feel like I can give it an adequate response on the spot, I'm going to kind of call it out. We're going to put a bookmark in it. I'm going to say, Chad, this is a good question for me to do a follow-up. And then I'm going to research the question, do the math, talk to somebody who knows more than me, try and get a good comprehensive answer for what is a great question that I'm unable to provide a compelling answer in the short term. And, maybe we'll put those into the ends of the question shows that we publish or something. I'm not entirely sure how we're going to do this, but I will, if I think it's a great question and I just don't know the answer, or I haven't, I don't have the material in front of me, you don't want to sit and watch me do math, then maybe we will, we'll go that route. So just keep that in mind. And then I guess I just sort of mashed the two rules together. So I think it's good. I think we're ready. Okay. Let's, Jason Plant says, it's okay, Fraser. I totally respect your opinion. You're educated in this field. I'm not educated in this field. So I am an educated layperson. I understand the lay of the land. I've talked to tons of scientists. I've had my questions answered about them, but I do not have a PhD in cosmology or astronomy or astrophysics or helioseismology or particle physics or any of that. And so at the very forefront of the field, people are trying to decide how they want to do their research, and they are having opinions, forming what they think are strong hypotheses for them, so that then they can follow up with additional research. And there is this instinct that we all have where we say, oh, like I know enough to have an opinion. I read this great book. I watched this YouTube video. I know a lot about space and astronomy and what people are discovering and all of that. And therefore, I think this thing is right. This feels right to me. And that is the trap that we have to avoid in our day-to-day communication of space and astronomy. The right answer is the scientific consensus says X, and that the people who are saying are against the scientific consensus have not been able to make a strong case why that is. So for now, the best provisional opinion that we should have is the scientific consensus. That's the safe way to roll through life. And every now and then the scientific consensus is going to be wrong. Of course it is. But if you want to be right most of the time about the nature of reality, the best thing to do is to follow the scientific consensus. Okay. All right. Whew. Let me just look through the questions. See, there's like nobody's had their questions answered here before. So this is fantastic. All right. Schnatz Grummelt. I remember something about gas giants having a solid core. Could Earth be turned into a gas planet giant if you just kept giving it more atmosphere? So there's a couple of misconceptions here. The first thing is this idea that a gas giant like Jupiter is really just a solid core surrounded by an atmosphere. And there's like bits of truth in that. There are many times the mass of the Earth in rock and metal inside Jupiter, that if you went and did a core sample all the way down to the center of Jupiter and you pulled out some of the material at the very center, it would be a lot of rock and metal. But it's not this really simple, there's the metal rock ball, or maybe there's even just like rock, and then inside that there's metal, and then around that is hydrogen, helium, which is most of the composition of Jupiter. And it used to be thought that actually that was the case, that you would start at the surface of Jupiter, you'd have these clouds of ammonia and methane, and then as you dug down deeper, it would just switch into just pure hydrogen and helium of varying densities, and like ridiculous densities. Like as you go down through the hydrogen and the helium, the densities just increase and increase and increase, and eventually you've got hydrogen, you've got hydrogen that is being turned into behaving like metal. It is under so much pressure. And then eventually you would reach this place where all of the material inside Jupiter had collected into the core. And thanks to Juno, they've been able to do a lot of sort of observations of what the interior of Jupiter is probably more like. And it seems instead that it's more like the interior of Jupiter has this very hazy distinction between the bottom layers of the hydrogen and the helium and the actual core. That is not this distinct boundary, that is instead this sort of mushy boundary between the two. And the question was like, why is that? Why would that happen? You would expect the heaviest elements to fall down to the very middle and collect into this ball. And the new research, and so people have done simulations, and they've gone and said, well, maybe it's caused by something being smashed into Jupiter. And so they ran simulations and found, like, if you hit Jupiter with another really large object, like hit it with a Neptune, then you're going to get this sort of mix up of the material at the center of Jupiter, but it's going to settle down very quickly, not take billions and billions of years. So in fact, that there is some kind of ongoing process with Jupiter that is keeping its internal state less separated into specific layers and more into just this kind of general hazy distinction and boundary. Now, with Earth, if you just kept adding atmosphere to Earth, then you would still keep that distinct boundary between the center of the Earth and the outer atmosphere. But that sort of internal structure of Jupiter appears to be the case with all of the large planets, that it's kind of similar at Saturn, it's kind of similar at Uranus, it's kind of similar at Neptune, for what we can tell, and is probably the case. And so who knows that if you add enough material, if you turn Earth into a Jupiter, that whatever is that process that is causing this sort of fuzzy boundary between the core and the atmosphere, you would probably get that with Earth as well. But this is, who knows if you turn a terrestrial planet into a gas giant as opposed to just letting a gas planet giant form the way that it normally forms through the interactions with the early solar system. Okay. Thad Anderson, how likely is it that the Rubin Observatory will find the asteroid that will eventually hit Earth, even if it is hundreds of years in the future? The Rubin Observatory is going to be coming online in just a couple of months now, and I could not be more excited. This is like the culmination of my excitement over many, many years. If you go back probably like 10 years, you will find me starting to get quite excited about the Rubin Observatory. And we're finally here. But we already had a proof of just how powerful this observatory is when they did some of their test imaging a couple of months ago. They released these images. And the one that I found the most exciting, not the really beautiful pictures of nebulae, although that was very interesting and very scientifically useful as well, but they did an 8-hour observation of looking at asteroids. And they were able to find 1,000 asteroids, new asteroids. So there's, they found many, many They found many, many thousands of known asteroids in their view, but they found 1,000 new asteroids in just this small period of time that they were looking at the sky. And that just demonstrates just what a prolific asteroid hunter is. That just shows what a prolific asteroid hunter Vera Rubin is. And the thought is that it is actually going to find, or it's going to submit many times more, five times more, 8 times more asteroids to the Minor Planet Center, which is this database that keeps track of all of the asteroids, than all of the world's observatories combined. There are already telescopes dedicated to finding asteroids. And if you add up all of those telescopes, all of the countries, all of the amateurs that are out there with their telescopes, everyone who's doing this work, suddenly Vera Rubin comes in and is just going to be dropping stacks and stacks of new asteroid discoveries onto the table. It's going to add millions of new asteroids to the database. And so, will Vera Rubin be the one that finds the asteroid that could risk Earth in the future? It will become the most likely place to announce the asteroid that is most likely, if there is an asteroid that is on a collision course with Earth in some time in the future, Vera Rubin will become the observatory that is most likely to find it. Yeah. Fraser, have you heard about this record-breaking object with Redshift 32? I haven't watched Anton's video about it, and I have not seen the research about this. So I'm not sure where he found this. So yeah, I am not educated. But Redshift 32 is kind of ridiculous that the galaxies that have been seen by James Webb are in the 14 redshift range, and that once you get beyond that, you're pushing into just, I don't know, 100 million. Let me see. I'm going to use the redshift calculator, the cosmology calculator. Okay, let me see. Universe. So that'll be 91 million years after the Big Bang, which is ludicrous and way beyond anything that anybody's ever seen. So the chances of that being true are very low. And I think if I remember, like even just seeing the thumbnail for Anton's, it was like, or it could be a planet. So assume a ridiculous claim like that will end up being not true. That's just your safe bet. Tesla and Final Fantasy. I don't know if it's been addressed yet, but have you heard anything regarding the uncontained fusion drives for space travel? Promising technology or pipe dream fantasy? So I'm not aware of the uncontained fusion drive idea, like an uncontained fusion drive versus a fusion drive. People have proposed fusion drives as a way of doing interstellar travel for a long time, and it's expected that a fusion drive will be a very powerful way of providing acceleration for a spaceship, especially here in the solar system. And there have been a couple of fusion drive concepts. I've reported on them. I've interviewed people who are working on them. NIAC will often fund a fusion drive or two every year, just because there are some really cool ideas and some amazing applications. We think about the solar gravitational lens. You could get out there in a decade. Get out into interstellar space. You could get out there very quickly and be able to start doing observations around us, or just traveling from Earth to a lot of targets in the outer solar system. Not only do you get the high delta V from a fusion drive, but you also get lots of electricity that you can use to power your science instruments. And so it's a very powerful idea and quite exciting. And, while people are working on fusion drives, or while people are working on fusion power plants here on Earth, and, maybe we're still a couple of years away from the ITER facility coming online. Other people are working on other forms of fusion. I think, it's always felt like it's going to be 30 years in the future, but I do think that we are now starting to drop that number down. Maybe we're 20 years away into the future. So fusion drives are exciting, and a lot of the applications for the fusion drives they don't have to be sustainable as a power system in the same way. So they can make a lot of compromises, they can work in different ways, and the technology might be actually super applicable, especially if you don't have to really worry that much about the radiation that you're putting out from your fusion drives. There's a lot of things you don't have to worry about when you put it in space. At the same time, though, of course, doing anything in space is harder than doing anything on Earth. So there are compromises. I think we are decades away from fusion drives operating in space. But once we do crack the code on these, I think they will end up being a mainstay of the way we get around here in the solar system. Like, think about the Expanse. That was super cool. But fusion drives are not sufficient to take you to other star systems. And because, the tyranny of the rocket equation, this idea that you need to carry an enormous amount of propellant to be able to accelerate your spacecraft, it makes a rocket, like a chemical rocket, a non-starter, right? You need the entire mass of the universe as your rocket propellant to try and accelerate you to Alpha Centauri. Ion drives are a non-starter that even though they are incredibly efficient and have a very high exhaust velocity, they're still not efficient enough to help you reach relativistic speeds. And unfortunately, fusion drives are the same. They are better than ion drives. They have a much higher exhaust velocity. They are very powerful, but you would still have to carry way too much fuel to be able to try and get to another star system at relativistic speeds. Try to go 10% the speed of light, 20% the speed of light. The solution that was proposed back in the 1970s, maybe it's in the 60s, is the Bussard ramjet. So instead of you carrying all of that propellant, all of that fusion fuel on board, what if you have a scoop that brings in fresh fuel as you're flying? And then you're able to concentrate that fuel down and put it into your fusion drive and then use it immediately. And then you don't have to carry fuel. That would work. That would solve the problem of you having to carry too much propellant. And we know that there is about a proton of hydrogen in every cubic meter of space around the universe. And so as you fly through the Milky Way, and it's probably a little higher as you're in the Milky Way, you're going to be scooping up all of these protons. You're going to be funneling them down into your fusion drive, and you're going to compress them and run the fusion drive, and you carry no propellant, and that would totally work. The problem is that the scoop part is the trick. And back in the day when the Bussard ramjet was developed, they didn't have the same math on what it would take to be able to do that. And more recent math has shown that, in fact, you would need to have a scoop, either a physical scoop or some kind of electromagnetic scoop that is channeling these particles. And it would have to be an astronomical unit long. It would have to be like 150 million. It would have to be like 150 million kilometers long. How do you project a magnetic field in a coherent form 150 million kilometers in front of your spacecraft to be able to guide particles of hydrogen into your fusion drive? So unfortunately, although the idea of a fusion drive is a really compelling concept and I almost guarantee will become one of the main ways that we travel around here in the solar system, because hydrogen is just so plentiful. You just hit a comet up, separate it into hydrogen and oxygen, use the hydrogen to power your fusion drive. It's going to work great. It's not going to carry us to the stars. We need forms of propulsion which provide either higher density of energy So antimatter is really the only one that's going to get us there. Or you are able to provide the acceleration off of the ship, and that comes from, say, a laser that is going to accelerate some kind of sail spacecraft up to relativistic speeds. And until then, unfortunately, every form of fusion isn't going to do the trick. Hey, Zaphan. No problem. We've got the... we're able to still pull the questions into the system. So the robot buddy is holding strong. Thomas Starkey, is the Oort cloud a properly coined term? People imagine it's a sphere encasing the solar system. Would calling it the outer extent of the sun's gravitational influence be more accurate? Well, I mean, I think the term the Oort cloud comes from, was it Jan Oort, who looked at the trajectories of all of the comets that were coming down into the solar system and said, well, they have to be coming from somewhere. And if you calculate the orbit of a comet on this long elliptical journey that they're making, then you can map out where this object began its descent down into the inner solar system. And it turns out that it has been falling for hundreds of thousands, if not millions of years, and has been traveling. If you just like trace out the ellipse that this comet is following, then you will go all the way out to this place that is going to be tens of thousands of astronomical units, hundreds of thousands of astronomical units potentially away from the sun. It can be 1 light year, it can be maybe even 2 light years away from the sun. And that is where the comets come from. But they're all coming from this, and they're coming from random directions around the sun. There's not some specific belt that lines up with, say, the plane of the ecliptic where all of the comets are coming from. They're coming from random directions. And so if you were to just like take each one and map out in 3 dimensions the origin, the starting point of each one of those comets, if you did that 10,000 times, 100,000 times, eventually you would have drawn out a sphere of dots surrounding the sun. That is the Oort cloud. Now, you know, your question, like, is it the outer extent of the sun's gravitational influence? The sun's gravitational influence moves at the speed of light. And so really the sun's gravitational influence extends out to 13.8 billion light years away from the sun. If you can see the sun, then you are experiencing a teeny tiny little bit of its gravity. So where does the outer extent of the sun's gravitational field end? It doesn't end until, unless you could move faster than the speed of light. And so, like, a lot of times people will sort of fall into this definitional series of arguments where they'll say, I heard that the Voyagers have left the solar system, but they're still moving through the Kuiper Belt, or they're still moving through the Oort cloud. Did they really leave the solar system? And the answer is, it depends on what your definition is of the solar system, the influence of the solar system, right? That there are a bunch of boundaries that you're going to reach. There's going to be the place where you pass the last planet. Is that the end of the solar system? There's going to be this place where you exit out of the Kuiper Belt. Is that the end of the solar system? There's going to be this place where you pierce through the boundary where the sun's solar wind is sort of filling up this volume of the Milky Way and is overwhelmed by the collective solar winds from all the other stars that are out there. And you get this bubble, the heliosphere, helioshock, heliosheath, heliopause, that are, different layers that are around the sun. Is that the boundary of the solar system? When you say that Voyagers have left the solar system, well, people go like, wait a minute, isn't it still being affected by the sun's gravity? Yes, of course it is. And it will be for 14 plus billion years, right? But this is the place, and it's not a gravitational thing. It's a pressure thing where the sun is putting out enough particles of solar wind that eventually they sort of stop being the main influence in the area, and now you're just getting the interstellar wind from all of the stars. Well, the sun is holding on to these Oort cloud objects all the way out to 2 light years-ish away, and that's like just barely overlaps what's happening with Alpha Centauri, and just barely overlaps with other stars out there. And that kind of makes sense, right? That there is a, we know that there is a Hill sphere around any object. This is the place where if you have a thing that's in orbit around it, it will stay in orbit around that thing. But if you get outside of the Hill sphere, then it will be easy to steal. And so objects that are out in the Oort cloud, as they go through gravitational 3-body interactions with each other, some are kicked down and perform this death dive down into the inner solar system, and others are kicked out and they fall off the Hill sphere of the sun and they become interstellar objects. And so as we discover these interstellar objects, we are finding objects that were no longer able to be held by their star through whatever reason. They were given a slight kick. Just a nudge is all it takes when you're out at the very edge, the very limits of what the sun can hold. So there's a million definitions for where the solar system ends, and you just want to be specific about which one it is. The Oort mist. Sorry, just looking through the questions. Hannes Kitz, Venus has such a dense atmosphere. Would it be possible to land a lander without parachutes? It should kind of float down, right? Yes, that's kind of what happens. So landing something on Venus is actually very simple to do because the density of the atmosphere is very high. So when you're first interacting with Venus, so if you send some kind of lander to Venus, you do need an aeroshell in the beginning to be able to decelerate it into the atmosphere of Venus. You've just got this really complicated, easy to destroy lander, legs sticking out as it's coming in the atmosphere at more than 10 kilometers per second, you're going to start to burn off all of that stuff in the same way that you need to have like a nice heat shield as you enter the Earth's atmosphere. It's a very similar experience getting into Venus as it is to trying to re-enter the Earth's atmosphere. Then, as you start to pass down through the atmosphere thickens up heavily. So you would still have the aeroshell. Then you deploy your parachutes, and now your spacecraft has dropped to terminal velocity, right? You're dropping down with the parachute, and parachutes work really well on Venus. You don't need very big parachutes, and they provide a lot of slowing down your spacecraft. And then at a certain point, you just let go, and your lander can now just descend and drop as if it is falling down into water. And once you reach the surface of Venus, the density of the atmosphere is the same density as water 1 kilometer below the surface on Earth. And so it would very much be the same thing as if you were just like dropping a rock, dropping a piece of metal into the atmosphere, and it will slowly descend down and touch down at the bottom of Venus with not a lot of velocity. So you have to, getting yourself slowed down and getting into the atmosphere is the hard part. But once you're there, it's actually a very easy time. And the Soviets, with their Venera program back in the 1970s and 80s, they sent mission after mission after mission to Venus. And they learned how awful the conditions on Venus are because their spacecraft kept dying. That they would reach a certain point, a certain depth in the atmosphere, and then the spacecraft would go offline. They're like, well, I thought we built it tough enough. We had lots of shielding, and we made it very heat tolerant, and we made it very tough, and was in a pressure vessel. Nope, Venus killed it. Okay, let's make it tougher. And then they sent another one, and then they got further down, and they're like, then it died. Nope, okay. And so finally, when they, it took several attempts, and they were finally able to actually drop spacecraft down onto the surface of Venus that were able to survive in the beginning for almost no time. And then after a while, they were able to survive, I think, to about, just around 45 minutes was the longest they were able to keep something alive down on the surface of Venus before they started to give up. They had done what they wanted. They took pictures of the surface of Venus, and it's a very different experience than what you would have. But it's kind of similar to, like, say, when people send probes to explore the interior of Saturn and Jupiter. When the Galileo spacecraft went to Jupiter, it brought along a probe that was released into the atmosphere of Jupiter. Same thing, aeroshell to slow it down, parachute to then slow it down to terminal velocity, and then it just fell down into the atmosphere, made it a couple hundred kilometers, and then was crushed by the high pressure and the increasing temperature as it fell into Jupiter. So dropping into gas giants, dropping into Venus, it's a very similar experience. Of course, a different landing, entry, descent, landing, and destruction profile. In excess, Fraser, do you think we should invest time in mastering interspecies communication here on Earth first before we try to contact other civilizations? I mean, we have no idea if any practice that we get communicating with other species here on Earth is going to give us any benefit in being able to communicate with another intelligent, advanced civilization. But there are benefits to learning how to communicate with other species here on Earth. Like, you can sense the intelligence of, say, if you've ever interacted with a parrot, or a crow, or you've seen the way a monkey or an ape is interacting with its environment. You can even see it with, like, a pig. And of course, people who work with dolphins and whales are finding that they're surprisingly intelligent. Octopuses are very intelligent in a sort of weird alien way. And people are coming up with different techniques to be able to test what they're, do they pass the mirror test? Are they able to communicate? Are they able to learn sign language? There's a lot of things that people are trying to do with other species. And I think that alone provides us with a tremendous amount of information. I think for the longest time, humanity has assumed that, we are the dominant species on this planet and the animals exist for our service. Whether it's to eat them, whether it's to have them do labor for us, they are meat robots that we use however we want. And that anyone would, do animals experience pain? Of course they don't. Do insects experience pain? Of course they don't, right? Because realizing that the meat slaves that we use for various things that we do causes them distress. And we are starting to learn the true nature of the distress that we are putting these animals through, both in our in captivity, in industrial slaughterhouses, things like that, and and what we're doing to them in nature as we interact with them. Boats are going by causing constant noise. There's a lot of really pissed off orcas in the Mediterranean, which are chomping on sailboats, or maybe they're having fun. Who knows? We should learn to be able to talk with them. And there's some really interesting progress that is going on. I know the SETI Institute and various marine biologists are starting to try to communicate with whales, and that sounds like one of the most interesting options that we have. And we could get to this place where we could have a communication with them. That would be mind-blowing. Or maybe we won't. Maybe we'll try all these different ideas. And the SETI Institute describes this as practice, as a way for us to be able to learn, as we learn how to interact with with another kind of intelligence here on our planet. This is going to give us some valuable lessons and tips to interacting with another advanced civilization. But sort of by definition, an alien civilization is one that is evolved in a completely different environment, that they share they share living in a universe with matter and energy, and that's about it. And clearly they have some sort of technological advancement that's allowed us to communicate with us. But that's it. That's all we've got. And who knows? And so I really love that science fiction explores these ideas. If you've watched the movie Arrival, that was a great movie about how do we learn to interact with a civilization that has very little in common with us, and yet maybe we can figure out a way to do it. And it's been well explored in science fiction books. Some great authors who have plotted out alien civilizations that are utterly alien to us. Greg Bear is a great author for this kind of thing, where you just go like, I don't understand these aliens, but they are a problem. And so I think it's going to be interesting. So just practicing our techniques, getting better at understanding the world around us is always a good thing. And gaining more compassion and understanding of the plight of animals here on Earth is very useful to us for living here on Earth as well. So all this stuff is good for us to do research. Ian Cudmore. White dwarfs can steal mass from their companions, eventually reaching the Chandrasekhar limit and going type 1a supernova, but do neutron stars have an equivalent? So theoretically, yes. We know that a white dwarf in a binary system with some kind of donor star is siphoning material off of that star and adding it to layers on the surface of the white dwarf. And sort of like the story of this is a little more complicated than we used to think. Like originally it was just, that some stars would be adding this material, they would go nova off their surface when they had accumulated too much material, and then they would keep going, and eventually they would gather enough material that they would explode as a type 1a supernova. But it now really appears that novae and supernovae from this process are two different things. That if you have a slow enough feeding rate, then this material gets absorbed on the outside of the white dwarf, it flashes off the surface, and then the process begins anew, and we see this brightening every number of number of decades, but it seems to go on forever. But in other cases, maybe when the rate of material that is being transferred from the donor star to the white dwarf is too fast, that it starts to build up, and eventually, as you say, you hit that 1.4 Chandrasekhar limit, and you get a explosion, which is 1.44 times the mass of the sun. And neutron stars appear to have a version of that as well, which is like about a little over 2 times the mass of the sun. And so you could have a neutron star that is very close to a companion star. And one of the definitions of this, they call them black widow pulsars, I think, is one example. So you have a neutron star. A pulsar is a type of neutron star that is very close to another star. It is pulling material off of that star. And the question is, is some class of supernovae that we see out there due to neutron stars feeding on material from a companion star, or a type of gamma ray burst caused by neutron stars feeding on material from a companion star? Because once you hit a certain amount of mass on the neutron star, it can no longer remain as a neutron star and will have to collapse to the next level. And there's some interesting ideas for what are some intermediate types of objects that you could get. One possibility is that you get a quark star. So like in the case of a neutron star, the thing is made of neutrons, that all of the electrons and all of the protons have been pushed together into neutrons. And then, but we know that neutrons and other baryonic atoms are made of quarks. And so it might be that if you push the pressure on the neutron star even further, then you're going to get a star that is made of quarks. And maybe you get this flash of energy as this process happens, as the thing goes one level down and now becomes like just barely bigger than a black hole. And then as it continues to consume more material, then it actually does make that final step and become a black hole. So this is all right at the cutting edge. There's a lot of really interesting observations. There's a lot of great telescopes that are trying to get to the bottom of this. And I think, back to the telescope that I'm most excited about, Vera Rubin, these are the kinds of things that Vera Rubin is going to be looking for, right? You're going to be scanning the entire sky. You're going to be looking for all of the stars that went supernova. Right now, astronomers know of about 2,000 type 1a supernovae, which are where those white dwarfs turn into supernova. Vera Rubin should find 1 million of them in 10 years, right? Like so many more. And then you're going to find all of the edge cases. So you're going to see all those type 1a supernova, but then you're going to see this smaller fraction. You're going to see thousands, tens of thousands of weird supernova that maybe we've only seen one example of them in the past. And now we're going to see thousands, tens of thousands. And that will allow astronomers to really finely slice down all the different kinds of events that appear to happen in the universe very rapidly. And we may finally have this really complicated flowchart that explains how you go from big star to supernova, from small star to white dwarf to supernova, from big star to neutron star to quark star to supernova to black hole and all that. And so stay tuned. I think this is going to be a really interesting time in our understanding of how stars evolve over time and die. And it's all going to be thanks to Vera Rubin, so stay tuned. ODS. If the 3i Atlas tail is reversed, does it mean it will slow down as it gets closer to the sun? So I've heard people say that the tail on 3i Atlas is reversed, and I think there's like some truth to this, that there is a slight anti-tail, but the new tail that is forming, we got some great pictures from the Gemini Observatory a couple of weeks ago, show that it's forming a proper tail, just as you would expect. That as it gets closer and closer to the sun, the tail is going to continue to extend. It may never get to be the point that we can see it with our own eyes. You'll need a small telescope to be able to see it, but it's going to be out there. And like, people are already starting to observe it. And the biggest telescopes are seeing the tail, and eventually the smaller telescopes will see the tail. The tail is caused by the interaction of the solar wind with the comet, that essentially the comet grows this coma around it. As it heats up, the gases start to sublimate off the surface of the comet, and they form this ball, this fuzzy ball of gas around the comet. And then as it gets closer and closer to the sun, the light pressure, the radiation pressure from the sun. So actually, you get the solar wind is hitting the coma of the comet and starting to bounce into those particles and then accelerate them away or push them away. All right, let me do this again. So as the comet gets closer to the sun, the solar wind particles strike these particles in the coma and push them away from the comet. And there's like two different speeds of solar wind, and so you get two different tails often as they're being driven away from the comet. And that's what causes this great trail away from the comet. And the tail always points away from the sun. So while the comet is going towards the sun, the tail is pointing away, and it feels very natural. But then as the comet is moving away, is past its closest point, is now moving out into deep space, the tail is still opposite to the sun. And the tail is not a thruster, right? That the comet, the thrust that the comet is experiencing as it is sublimating these materials off of its surface because it's heating up is kind of random. That in the comet is turning it's heating up. Chunks of gas are starting to be streamed out of the comet, and they, some are pushing the comet a little to the left, and others are pushing the comet a little to the right, and a little up, a little down, a little back, a little forward, and it all just sort of evens out as the comet is turning, and jets of material are coming out of it, and it balances out. And then once that gas is out in space, then it's pushed away by the solar wind, and so it is not a thruster that is coming off of the comet, and so it has nothing to do with the actual sort of direction that the comet is going, unless the material is sublimating in a way that is uneven, that if there's some place that is causing, more gas is venting out of one side of the comet than the other side of the comet, and the comet isn't rotating, then you will get some kind of uneven movement on the comet. And this is something that people thought might have been happening with Oumuamua, that there was like this weird, unusual movement from the comet, probably because it had some kind of unbalanced escape of gas off of it. So no, it's not going to slow down. It's going to follow this precise trajectory that has been mathematically worked out, and any deviations from that trajectory are going to come from any uneven sublimation off the surface of the comet. I love the conversation about slugs here in the chat. This is awesome. We have so many slugs here in our garden, and they will just absolutely devastate my plants. So my wife and I do a slug hunt every night, where we walk around, gather up all the slugs, and take them down to a pond that we have and release them so they can fend for themselves. But also there's a lot of ducks around that pond. So, who knows what happens to those slugs after that. Montgomery Wood, what resolution would be possible if you combined the dozens of telescopes throughout the solar system into one? So the idea that you're talking about here is interferometry. And this is this incredible concept that if you, well, let me get an idea. So this is this incredible idea that if you separate telescopes by some distance and you align their observations down to the wavelength, right? Like if you think about visible light, it's going at, hundreds of nanometers wavelengths, right? Every second that goes by, countless wavelengths are going past you, and if you, in two locations, you can line up those two wavelengths down to the specific nanometer, then you create a telescope that has the resolution of the separation of those telescopes. So if the telescopes are 10 kilometers apart, and you're able to align their observations, the light that comes into them, down to the specific wavelength, then you get an interferometer, and now you have a telescope that is 10 kilometers across, which is incredible. And this has been tested out. There's a telescope here on Earth called the Chara Array. It's in the US, and I think the telescopes are separated by 300 meters, and it's a visible light telescope. And some of the most detailed observations of the surface of stars have been taken with the Chara Array because they are separated by this enormous distance. They're acting like a telescope that is hundreds of meters across. But the downside with an interferometer, and there's like the first downside, is that you get the resolution. You're able to pick out details on the surface of something, but you don't get the ability to see faint objects, because really you're still, if you've got two 1 meter telescopes and they are separated by 300 meters, they're only seeing with the amount of light gathering capacity of those two small telescopes. Yes, if something is incredibly bright, then you can reveal features on it. So you can look at stars, you can look at the sun, but you can't look at faint things. You can't look at galaxies, things like that, can't look at nebulae because they're very faint, and you require very big telescopes to see faint things. So what you're asking is the equivalent of this question, which is like, okay, so we know that there are a bunch of telescopes that are around the solar system. We've got, say, a 0.5 meter telescope on the Mars Reconnaissance Orbiter, which is tens of millions of kilometers away from the Earth. You've got the Hubble Space Telescope. And so if you synchronize the Hubble Space Telescope and the Mars Reconnaissance Orbiter, you would be able to build a telescope that is tens of millions of kilometers across. You would have the resolution of a telescope that was tens of millions of kilometers across. And yeah, maybe you can't look at lots of stuff out in space, but maybe you could look at Betelgeuse and get some answers. Maybe you could look at really bright stars and try to get some answers. And so theoretically, the answer is yes, you could do that, right? You could record all of the light that came into the Hubble Space Telescope, record all the light that came into the Mars Reconnaissance Orbiter, and then you would line up that light perfectly to the point where you get this interferometer forming between the two of them. Practically, it is impossible because you are getting, 500 nanometer wavelengths. You're getting so many photons that are going past. How do you know which is the photon, right? Which is the wavefront that you're going to try to line up? The only way this post process works is with the longest wavelengths. And that's why I say the Event Horizon Telescope, which is this worldwide telescope network on Earth, where you've turned all of planet Earth into a giant telescope. It only works in the radio waves because the wavelengths are very long, right? They can be many centimeters long. And so you can just record all of the data coming into the telescope, and then you can, with an atomic clock, and you can measure as the wavelengths are going past. And then you take all of those hard drives, you take them to some place, and people crunch all of the data in and line up the time codes so that those wavelengths are lined up. And suddenly you're able to use telescopes that are really far apart to be able to image the shadow of a event horizon around a supermassive black hole that is tens of millions of light years away from us. But once you move into the visible spectrum, infrared, all of these, then the only way that you can make this work is if the telescopes are relatively close to each other and they are connected with a fiber optic cable, and you are watching very carefully for anything that is going to change. Like if a truck rolls by, that's going to subtly change the length of the cable, and now your interferometer is busted. So there have been, it's an incredibly powerful technology, and there's some really interesting ideas. People are suggesting quantum telescopes so that you could theoretically just automatically collapse the wavefronts down and pull out the data without having to do this time code thing. And I'm researching this right now. We'll probably have an interview about this soon. But just like in general, unfortunately, it's just practically too difficult to do. But some of the best ideas that I like are these space-based interferometers, that if you did this on purpose, like you take two telescopes, you take them to space, you set them up so they're firing a laser towards each other, and then they're aligning their distance down to the nanometer so that they're able to be perfectly aligned. They're gathering their data. They are acting like a telescope as big as the separation in between them. This is the kind of work that's being done with the LISA experiment, which is going to be maintaining this space-based interferometer to detect gravitational waves. People suggest you can do this physically on the moon, that you can set up multiple telescopes, separate them by however many meters, hundreds of meters that you want, and you will suddenly create the most powerful, highest resolution, highest sensitivity interferometer, visible light telescope that's ever been built. These are all great ideas, and they should all be done. And, if there's more funding for space and astronomy and for space science and for upcoming missions, I think we would see this. People have been trying to build interferometers and propose space-based interferometers for decades, and they just end up being too expensive, too complicated. Nobody's able to do them. So for now, even though you could create a telescope, like if you put a telescope on either side of Earth's orbit, you would have a telescope that is 300 million kilometers across. That would be amazing. That's a very big telescope compared to the 10-meter telescopes that we have down here on Earth. That would be incredible. And if you put lots of them around the orbit, you could create this big ring around the Earth's orbit, and you could combine all their light, and you could see with a Event Horizon Telescope the size of Earth's orbit. That would be great. But it's just, when you think about all of the gravitational interactions between all the objects in the solar system, moving the telescopes around, if you move them a couple of nanometers, they're out of alignment and they no longer work as an interferometer. Pak Jahan, if we discover that ancient life found on Mars is linked to life on Earth, would Venus also be in line to have picked this up? So the idea of life moving from world to world, this is this concept of panspermia. And it seems fairly theoretically possible that if a large asteroid crashes into Mars, kicks up chunks of debris into space, the debris floats around for a few tens of thousands, hundreds of thousands of years. It's able to protect life inside the asteroid. Then as it re-enters the atmosphere of another world, or as it enters the atmosphere of another world, it heats up, breaks apart, but it doesn't heat up down in the middle of the rocks. And so the life is able to survive the journey. And, we have examples of Mars meteorites here on Earth. We know this process is happening all the time. Some percentage of the meteors that we see in the sky, the meteorites that fall on Earth, came from other worlds, came from the moon, came from Vesta, came from Mars, theoretically have come from other places like Venus. We haven't found one, but theoretically, these things are happening. And we're all quite excited about this announcement from NASA that Perseverance rover has found something that so far they haven't been able to come with a natural explanation for how it formed, apart from it being a residue left by life. And of course, it needs to be studied in the lab, but it is an incredibly exciting discovery. And if it does turn out that this is bacteria that created this, and although we wouldn't be able to test the DNA to find out if we share a common ancestor, we would be looking at the kinds of things that the life is doing. And if it is very similar to what Earth life does, it does make sense that the life on Mars is related to the life on Earth. Then could it be that there's life on Venus? People are fairly convinced that the conditions in the upper atmosphere of Venus could theoretically support life, that it's nasty down on the surface, but once you get high enough and your bacteria is aloft in the air, which happens here on Earth, right? We know there's bacteria aloft at tens of kilometers altitude, just floating around, then they've been able to work out a life cycle that life could survive. And there are extremophiles that with certain evolutionary changes might be able to live on Venus. And so if there were particles from Mars, maybe there was life on Mars, and then that was shared to Earth, because Mars is the lower gravity world. That then makes sense that Mars could supply life to Earth and could supply life to Venus. If that's the case, then maybe it took thousands of tries, but eventually something was able to take hold on Venus. And so there could be life on Venus. I mean, there's a lot of really interesting places where once you start to think about it, there could be life. Obviously we have all of the icy moons and icy worlds around the solar system that once you get down through the ice, you've got these conditions, liquid water, volcanism that is spewing nutrients into that water, various organic compounds, dissolved hydrogen gas that's food for bacteria. Those conditions would be perfect for life here on Earth. And so it could very well be that if life was getting around from world to world, it made it to Europa and Enceladus, and it made it to Callisto and Ganymede, and maybe all the way out to Pluto. And then you can even imagine more exotic ideas, like there's no life on the surface of the moon, but the temperatures increase. There's probably water in the interior of the moon. And so as you go down deep enough, you get to this place where the water on the moon is going to be a liquid, and there's plenty of rocks and material and various volcanic activity still inside the moon. Not very much, but still. Same thing in Mercury, right? That suddenly you start to go, well, life could be everywhere. across the solar system, if life can get around from world to world, if hardy extremophiles can survive the journey, the arrival, and then find a place to set up shop, we might just keep finding life again and again and be able to trace it back to a common ancestor somewhere here in the solar system. Maybe even not on Earth. Maybe life formed on Mars and then moved around to the rest of the solar system. So we're really at the beginning days of this hunt, and we need to search more. We need to get better at finding evidence and bring it back to Earth where we can study it as we explore the solar system. S. Johnson 2828. How much Vera Rubin data has been given to the public, and when are data sets being published? Vera Rubin is still in the commissioning phase, so it hasn't actually gone into its live phase yet. And I forget the exact date. It's going to be in November-ish, I think, so near the end of 2025. And when it does go online, it's going to be providing essentially all of its data to the public. There's going to be a real-time feed which astronomers are going to use for whatever thing they're most interested in. If they're interested in asteroids, they're interested in supernova, they're interested in gamma ray bursts, they're interested in planet nines, that they're going to be watching this real-time feed, because the sooner you discover these things, the more time you have to be able to watch the earliest phases of this, like a supernova. Like when a supernova goes off, the most interesting time is within the first few hours of when the supernova is going off, because you're seeing this rapid change in the elements, you're seeing all of this stuff. And so you want the notification from Vera Rubin that a supernova just went off, so that you can point whatever telescopes you have available to you to do follow-on observations. And so it has to be real time. And they're not, they're releasing all this information publicly. And then the other thing that they're going to be doing is they're going to be storing all of these data in giant archives that then anyone who has a question about what the universe was doing in the past can go back and pull from the data archives and run queries against it to be able to pull specific images. Like you'll say, okay, show me this tiny spot in the sky on, for all of the dates that Vera Rubin has observed it. And then you'll be able to pull up all those images. You'll download them into your software so that you can then run analysis on that. And this is all going to be available, not only to scientists, but available to the public. And so if you're good with databases, good as a programmer, you can go and be able to, scan through all this material yourself and look for whatever you want. So no, it's all being made available to the public, and all the data sets will be made public. Now there's like one slight caveat, which is that the Department of Defense, I think, is going to be removing their satellites from the view, so that other nations can't know where spy satellites are. And that was sort of one of the requirements of their funding of the project. But apart from that, everything's going to be publicly available. Toxis. Can Chandra, Juno, and others be saved by a rich philanthropist, ESA, or Patreon? Yeah, I get this question a lot, which is, we've been talking about the potential shutdown of 41 missions at NASA, which have been requested by the White House administration. And, the actual carrying out of this plan is still a little bit unknown. We're about 3 weeks away from the date when the funding will get shut down unless somebody does something unusual. Like unless Congress actually puts together a plan that is different from the one that the White House has requested, the one that the White House has requested is going to go through. And, seeing how little pushback there is against the decisions by the White House, I don't have a lot of hope. So when that happens, then a bunch of missions that are already operational are going to get shut down. Things like Juno, things like Chandra, a bunch of missions that are in the works are going to get canceled. We're not entirely sure. Looks like Dragonfly is going to make it. Nancy Grace Roman will get canceled. The Mars Sample Return mission is getting canceled, although that was sort of already done for. So we're going to see all of these missions get shut down. A lot of Earth observation satellites are going to get shut down. A lot of climate satellites are going to get shut down. And so what do you do with that? Well, people are like, why can't somebody save it? Why can't rich philanthropists just take over those? Well, the amount of money it costs to maintain a satellite that is already operational is not that expensive. Like the spacecraft is already there. It's still going to keep orbiting whether you're communicating with it or not. And so you're probably looking at tens of millions of dollars per year to maintain operations for a lot of the spacecraft, the Voyagers, things like that. So it is theoretically possible for a philanthropist to take over, theoretically possible for ESA to take over operations. The Canadian Space Agency, that's the kind of budget we like. We could take it over. So I think there's a possibility that you could do that, but I don't think there's any political will to do that. I don't think there's any, there are security issues to hand over stuff that requires security privileges to be able to work with. There's software, there's code, it's a mess. And you don't just easily hand over, this entire operation to some other nation. And so the looks like the plan is going to be just shut it down, just turn it all off, turn these spacecraft off, turn off those eyes that we have in the cosmos because the administration wants to spend that money on other things. And, I deeply disagree, right? I'm pro space, more space, please. But this is the decision that they get to make. This is a decision that the people who voted for them want made. And so this is going to happen. Or Congress is going to stop it. So we'll see what happens. I will report right to the bitter end, and then I will report mission by mission as they go offline or don't. $1,000. If we're expecting to discover thousands of interstellar objects every year, at what point do they stop being newsworthy? Pretty quickly, I think. We're not going to discover thousands, but we will discover dozens. 6 to 12, maybe more. Interstellar objects will be found every year. So I think we're going to get pretty excited about the first few. And then after a while, we'll stop talking about it unless something really interesting is found. It's the same way with exoplanets. Like how often do you hear me talking about, I don't announce every new exoplanet that has been discovered. I talk about some really interesting ones, the ones that are at the edge, but I don't talk about all of them. I don't announce SpaceX Starship launches. I don't announce SpaceX Starlink launches. It's just like more satellites going into space. It's the thing we've seen. I don't report on airplanes flying either, right? Like at a certain point when this becomes commonplace, then we shift from announcing each individual object and obsessing about it into the larger meta understanding of the phenomenon in general, which is what we're doing with exoplanets. We've classified exoplanets. We talk about concepts in astrophysics. We don't report on every single supernova that astronomers have found. We don't report on every gravitational wave. Like there are gravitational wave events now happening about once a week that LIGO, Virgo, Kagra, they are detecting colliding black holes about every week. We don't talk about it anymore because now the deeper question is like, what are we seeing from all of the gravitational wave events? What is that telling us about the nature of colliding black holes, about the evolution of black holes? Those are the questions that we shift into, that we will still be reporting on. So there will be this time when an interstellar object will be discovered, and I won't tell you because it's just not news anymore. And that's just natural. And then we'll move on to other weird things that we find for the first time, because that's news. Please collaborate with Mr. Beast. Sure, yeah, if he wants to. Like, wouldn't it be cool if Mr. Beast wanted to do some kind of philanthropic effort to get telescopes into, every school around the world, and they could build a big interferometer with all of them? That'd be cool. Matt Hankey. If China does Mars sample return before NASA, will they take the Chiava Falls type rock, or will they straight up take the Perseverance samples? So right now we're talking about this really cool rock that the Perseverance rover studied, which has what appears to be ancient evidence of microbes in the, mixed in with this sedimentary rock. Now, there are other possible, abiotic explanations for it, but NASA, the researchers working on it, have worked through every single possibility and have ruled them all out. So they don't know how they could have formed not with life. Doesn't mean that life formed it, but the researchers haven't figured out a way to get there. And so it is probably the most interesting rock that has ever been found on the surface of Mars. And it would be absolutely incredible to bring that rock back to Earth. So could the upcoming Chinese Mars sample return mission return that rock? Absolutely, right? That they're going to have to pick some target on the surface of Mars, and they're considering various candidates for their scientific utility. And the Chinese version of the Mars sample return mission, the one that's going to be flying in 2028, is planned to be kind of more quick and dirty. It's going to fly to the surface of Mars. It's going to fly to Mars, land on the surface, look around, pick up some interesting rocks, put it in a collection, and then blast off the surface of Mars and bring those rocks home. And then researchers in China and around the world will get their hands on the first samples, fresh samples retrieved from Mars. But you have to land somewhere. Why not land right by that really interesting rock that Perseverance found? Now, landing with that level of precision. Now, like, China knows where that rock is. NASA has been keeping a very detailed catalog of all of the motions across the surface of Mars. We know exactly where this rock is. Anyone who is able to navigate at the surface of Mars could land at this rock. Now, who knows if it is a very safe landing spot, right? It could be jumbly. There's lots of terrain around there. It's not safe to land on. So you probably have to land close to it and then deploy some kind of rover that could retrieve the sample. That makes your mission more complicated, adds mass to it. They're really trying to dial down the mass and complexity of this mission. So it's just grab and go. But the thing you're mentioning is, could it grab one of the Perseverance samples? Again, those are tagged. They're on the surface of Mars. Now, those are the backups. So Perseverance is carrying samples, its main samples, inside of itself. It has a sample collection component that is carrying inside of it. And then it's also dropping backups of its samples across the surface of Mars. So if something ever happens to Perseverance, you could go and collect those backup samples. So theoretically, again, the Chinese mission could land right where the sample is that was dropped on the surface of Mars and pick it up, and then that's what it brings home. Could it do that? Again, theoretically, yes. But you've got to land exactly on top of the sample, which is going to cause damage to the sample with your exhaust plume. So you got to land near the sample, then you got to send a rover, which, maybe the Chinese Mars sample return mission is going to have a helicopter, but we're still not entirely sure exactly what's going to be on board. And then, does it create an international incident? I don't think so. I think that scientists in general would like to get their hands on samples of Mars, and especially the most interesting rock that's ever been found on Mars. They would like to have that brought back. And I think American scientists, European scientists, the people who helped contribute to the funding of Perseverance, ideally would like to have those samples in the hands first of American researchers and then share that knowledge with around the world, which is like generally U.S. research is more public, more transparent than the research that comes out of China. But China is sharing their information with the public. They are sharing their samples of like their lunar samples with other nations, and they are sharing and publishing a lot of papers on the work that they're doing. So it's not like it's this completely closed scientific community and you only hear what they want you to hear. It's a more permeable boundary where some things it is kept very close to the chest, like, especially when it has military implications, but other cases there's a lot of collaboration that goes on. The FAST telescope, which is, 500-meter telescope in China, a lot of foreign researchers go and do work on this telescope and get their information out. There's a lot of interesting collaborations between China and other nations. There's a telescope, the Einstein probe, which is a collaboration between Europe and China. And so they could have various collaborations baked into determining some of this research. And from the lunar samples that the Chinese have already brought back, they have shared a lot of samples with other nations, other scientists, that people can study this independently. So my guess is it'll be a blend of that. Like it's a huge bragging rights to say we brought samples of Mars back. We brought that specific rock back to Earth so that people can study. And you don't own that rock. Nobody owns that rock, right? That anyone is free. If you can get there and you can dig a little chunk out of it and bring it home, then that's fair. Right. So I think it would be, for the U.S., they would feel, a little frustrated because they had found the rock and would love to get the samples. But at the same time, they're canceling the sample return mission. And so I think in general, if you asked most U.S. planetary scientists, would it be all right with you if China went and grabbed that rock and brought it home? They'd be like, yes, that would be fine with me. And I hope they share. I do get your Londo Mollari voice reference, which is from a Babylon 5. But I cannot do a Centauran accent. Where are we at? 9:30. Okay. Crease, just to get an idea of how expensive spaceflight is, how much more expensive would the gold be if it was orbiting in the asteroid belt? 10 to 100 times the price of Earth gold? Way higher than that. So the current best asteroid sample return missions that have been done, you've got the Hayabusa 2 mission and you've got the OSIRIS-REx mission. And let's say that they are in the $1 billion range, and both of which were able to bring home about 100 grams of material. I think Hayabusa brought about 100 grams. OSIRIS-REx brought home 200 grams. So let's say 100 grams just to keep it really safe. So you're going to be spending $1 billion per 100 grams. So what is the current price? Gold price in per kilogram. today's gold price in kilograms is $120,000. And so you're bringing back 1/10 of a kilogram. So you're spending $1 billion to bring back $12,000 of gold. So 1 billion. Is that right? 1 billion divided by $12,000. I should Wolfram Alpha for this. Let's do that. See, this is the math. This is the thing that's boring. So $1 dollars. So I'm trying to think of like per gram. So 100,000. So you're spending $100,000 to bring back $1 of value. So it's 100,000 times more expensive to bring back gold from space than it is to dig it up from Earth. And that is like, that's the number. And so again, if there were bars of gold sitting right there on the surface of and that's assuming the gold was just sitting there in a nugget on the surface of the asteroid to bring it home. You're going to look at 100,000 times more expense than what it would be to do that here on Earth. And like at this point, people are going to start to bargain and be like, well, you know, like maybe you could make a bigger spacecraft and maybe you get better at this and maybe, you know, this becomes valuable. Okay, great. So maybe now it's 10,000 to 1, right? For every dollar you invest, for every $10,000 you invest, you make $1. Oh, no, maybe it's 1,000. Okay, all right, great. So now for every $1,000 you invest, you make $1. Okay, well, maybe it's 100. Okay, great, right? Now we've gone however many orders of magnitude, right? For 4 orders of magnitude, now it's $100. For every $100 you spend, you make $1. That's still a bad business, okay? 10 to 1, terrible. 1 to 1, now you break even, right? We've gone through whatever, six step-ups. That's not a good business still. 2 to 1. Okay, finally, now we're in return on investment territory, right? For every dollar you spend, you make $2. Okay, great. So that was a lot of doublings, or times 10x's of your ability to return this stuff. So yeah, the gold is there, and it's worth a lot if you can actually get it into your hands down here on Earth, but you can't. In a way that is affordable. And it's like, this is the Achilles heel of any asteroid mining concept that anybody is going to have, is that the cost to bring this stuff home is outrageous compared to just digging a hole in the ground and pulling this stuff out, in filtering seawater for all of the gold that's in it. Melting down computers to be able to extract the gold from it, that we know better return on investment ways to be able to do this. And as soon as you do this kind of math and you're like, how long can you run a business where you spend $100,000 to make every dollar? Like only in AI can you do this. So we're going to have to wait until our space-based infrastructure has gotten so good that this stuff starts to make more sense. And the reality is it will never make sense. It will never make sense to bring material from space and bring it back home to Earth. That it does make sense when you're out in space and now the economics have flipped upside down, that you're instead saying, okay, we're landing on an asteroid and we need to be able to find propellant. We need to be able to find building material, and the stuff is going to be right there on the asteroid. That's where we get it. Or maybe we deliver it from another asteroid that's relatively nearby. That's cheaper than us trying to launch that material from Earth. But you know, whenever you look at the value of an asteroid and go, oh, that thing is worth $4.3 quadrillion. Yeah, and it would cost you however much quintillion dollars to actually bring that home. next page? No. Wait, are we? Okay. Aaron T, how do you feel about the rising number of fake space videos made by AI? I am against it. It's terrible. It's a plague. And the thing that I don't think you realize is how much YouTube is complicit in this. So if I go to my, and any creator that does this, if I go to my YouTube channel dashboard and I go to content, the leftmost, like most important tab in the content tab in the YouTube studio, and hopefully Chad will be able to show this, is inspiration. And that is ideas that you should make, and it's filled with AI. So they think that I should make a video about Mars life detection, beyond methane, what's next, Mars sample return, SpaceX Starship alternatives, ancient impact theories, debunking the misconceptions, space debris, a looming threat, fusion power, energy revolutionizing space travel. And then YouTube will give me a thumbnail that is AI generated. They will give me a script outline that is AI generated, and then they'll be willing to just write my entire script for me. And I say, no, thank you. That is gross. I don't want any part of that. That's the first part of this. The second part is if you go into the analytics tab of your YouTube and then you click over on the trends, then you get a list of videos that are similar to what you're doing. Essentially, these are the videos that are trending in your field right now. And again, I can't sort of show you the list, but let me see. Every single one of them is AI slop. So new videos to inspire you. And that the first video says 3i Atlas is super intelligence from deep space. 3i Atlas is much bigger and stranger than we thought. Oh, that's Angry Astronaut. Okay. NASA's new report reveals that 3i Atlas's body is growing. James Webb Telescope just warned the world. 3i Atlas, why is NASA hiding what they found? Nobel winner warns the James Webb Telescope just found something. The U.S. shut down James Webb Telescope after this was found. Like, it's all spam. It's all AI slop. They're not just like being confused and showing me a couple of AI slop videos that are trending in the field right now. They are 100% slop. Right? Like, except for Angry Astronaut, who I just disagree with, right? But at least it's not slop. So this is the state of what YouTube is not only permitting on their platform, but is finding exciting. It's titillating. Like they're, ooh, this is what we like. This is good stuff, right? Finally, instead of encouraging people who are space journalists or scientists to communicate the actual work that's being done by scientists to the public, let's just double down on garbage that is being generated at top speed with AI on top of AI, generating AI videos. Like, you can use every part of the Google AI stack, right? Like, you can use Gemini to generate the outlines. You can use Nano Banana to create the thumbnails. You can use VO3 to create the video. You can use Google LM to be able to do the research. You can put the whole thing together. And then you can just start to use Google Gemini to code up all the connections so the stuff all gets generated. Go into the API, press a button, out pops a video, uploads directly to YouTube. You can do this 10 an hour, 100 an hour, 1,000 an hour. Keep going, right? Like, that's where we're going. And like, how can they be okay with this? Right? Like, this is not good for the future of Google. This is not good for the future of YouTube. This is bad because it is going to drive the value of information on the YouTube down to zero. That you're going to look at, that a person's going to go like, I want to watch some YouTube today. Let me see what's going on the YouTube. And it's just slop, 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 right? It's like, I'm going to eat some breakfast today. Let me see what's in my compost bucket. Slop, slop, slop. That is going to be the future. And they will have destroyed all of the goodwill, all of the value of their platform because they are trying to jump on the AI revolution. And that, like the Hail Mary, maybe, just maybe, the AI is going to get so good so quickly that they will have dodged a bullet, that YouTube will come out the other side of this, where the AIs are making videos that are genuinely good, well-researched, high quality. I don't think that's going to happen at the rate at which they're destroying their brand. And so we will get to this place where one after another, we will abandon YouTube as a place where we go to be entertained. And we will fragment off into people who just want to watch algorithmic slop because it, is titillating and they enjoy what's being served at them, just despite its, how much it is connected to reality and how much of it is going to be hived off into small communities. So like I am, I've talked about this quite a bit, that I am doubling down, tripling down on Patreon over there, right? Don't let the algorithm tell you what to watch. Come join me and this amazing community over on Patreon, where I give you additional content, longer videos. I answer your questions. I interact with the audience. That I'm going to create this haven, this place where you guaranteed that you're going to get good human-based space reporting on a regular basis that meets all of your needs, and you don't have to dip your toes into the algorithm. You don't have to dip your toes into the algorithmic. Let me say this one more time. You don't have to dip your toes into the algorithmic slop pile. You don't have to search for your breakfast in the compost bin. You can get nothing but high quality, top grade, human created content for you. So how do I feel about it? I am against it, is how I feel about it. Fraser, Clark Holt, Fraser, you should just live stream on Patreon too. Yeah, I really should. Like, I should stop doing this here on YouTube. And I should start just doing this on Patreon. Like this is where I'm getting to, which is that I will do the first hour on YouTube, do the first half hour, do the first 10 minutes on YouTube, and then do the rest of it over on Patreon. If you want to continue watching, come join me on Patreon. It's completely free. It's publicly available. There's no ads. There's no reason except you're habituated to this platform that is destroying its value in front of you, in front of your very eyes, making your experience more miserable every single time you come and use this. And you're exactly 100% right. Oh, it makes me so mad. So mad. Because it didn't have to go this way. Like, YouTube was the one social media platform that had resisted enshittification, that I consider to be valuable. The only one that I consume and watch is this one here. And now it's starting to become terrible. Yeah. It's like grieving a friend. Gorilla Shia. Do you agree that the best candidate for finding technosignatures is our moon? It's like a museum, perfectly preserving any crafts or orbiters that it may have visited us in the last 4 billion years. Yeah, absolutely. Like this was the plot of 2001: A Space Odyssey. Spoiler alert, if you have not watched 2001: A Space Odyssey that came out, whatever, 50 years ago, 60 years ago, I'm going to spoil the plot. And the gist is that people find a monolith on the surface of the moon that tells them that aliens were here and that they want to learn more about the solar system and that these things are scattered across the solar system. And the reason why you would want to put something on the moon is because it is geologically stable, that there is no weathering, that you could put something there on the moon and you could show up, drop a monolith on the moon, and then keep going. And you know that when the civilization on the planet gets advanced enough that they'll be able to send a spacecraft to the moon, they will find your record, and it doesn't matter when they actually pull it off. And so it's not just like it would be inconvenient to put it on the moon, but if you put it down on the surface of the Earth, it's only going to last about 1 million years before geologic processes, weathering and stuff tears it apart and it's gone. Put it on the moon, it's there for billions of years. You can still find it. And so I really like that idea that the best place for us to be able to find evidence of, intelligent civilizations is going to be here in the solar system. There's potentially we could listen to signals coming from another solar system. Potentially we could find microbes, right? But really, the thing that we're probably going to find is we're going to find some remnant of a von Neumann probe that passed into the solar system, started to make more copies of itself, try to send those out into space, left the factory behind, and we find the factory floating in the asteroid belt. That would be very cool. And if they were like really trying to be polite house guests, they would leave us a monolith or something on the surface of the moon that would contain really useful information that would advance our scientific understanding of the cosmos. And there was a great idea, like David Kipping talks about this, that even if we don't find those relics here in the solar system, then we can produce the relics, that we can go to the moon and we can set up some kind of archive, some kind of monolith of our own. We could literally build a monolith and put it on the moon and put a bunch of really useful information, carve into the monolith, really useful information that we know is going to last 1 billion years. And that when the octopuses take over planet Earth and they build their squishy spacecraft and they head off to the moon, they will find evidence of that humans were here. And they'll see pictures of us and go, oh, interesting. Right? Though there was an intelligent civilization on Earth before us, and they'll be able to find out more. And so we can communicate not in real time, but like what is communication in real time out in space, right? We can communicate through time to other civilizations that will be arriving, will be forming on Earth after us. And we can send our wisdom, send our information, teach them a good recipe for the barbecue. We can do that through time. And it's a great idea that even if in our lifetime we will never communicate with another civilization out there, we can give the following civilizations the gift of communicating with us. You can roll your eyes at the gift, right? But yes, it would be cool for us to be able to communicate or at least read messages of a precursor civilization. And so we can be that precursor civilization for future intelligent civilizations that arise on Earth. Oh, now we're on the second page. See if that works. We are the old ones. Yeah, I like that. Okay. Oops. Not octopus's slug life. What was that Futurama, right? It was like, oh, they blew it up, and then uh, the monkeys took over, and then they blew it up, and then the cows took over, and then they blew it up. And what is that? Like a slug baby? Fantastic Al. What solar body, planet, moon, asteroid, or comet is the most interesting to study right now if you could choose? Uh, I mean, I'm most excited about Titan, I would say, right? Like Titan is this multi-layered world that is very interesting. You have interior wise, it's very similar to the other large moons in the solar system, like Europa or Ganymede or Callisto, where you've got this thick ice sheet, that could be tens of kilometers thick. And then you've got this ocean of liquid water that's beneath that is surrounding a rocky center that has probably some amount of volcanism that is injecting material into the ocean. But then surrounding that, you have this layer of organic material that, because Titan is so far away from the sun, organic molecules are able to form naturally in cold conditions, and you have methane lakes on the surface of Titan. You have rain of methane. You have just organic molecules. They are the dirt on the surface of Titan. And so theoretically, there is some kind of process that is transporting material from the surface down into the interior of Titan. And you've got this mixing of organic material with the liquid water, with the additional dissolved hydrogen gas, things like that. And so you could have life, I think there, but that, and then it's just such weird terrain. Titan has an atmosphere that is thicker than the Earth's, that you could walk around on Titan and it would be very cold, but you wouldn't need a pressure suit to stop the low atmosphere from causing damage, the low air pressure from causing damage to your body. The mountains are made of ice on Titan. They're not made of rock. They're made of ice. Everything is so cold. That sand dunes form of ice particles and mixed in with organic material. That there are these lakes, these seas of liquid methane, that you could get a boat. A boat would like a sailboat. You could sail on Titan around on these lakes. That you could send a submarine on Titan that could go down below the surface and head down to the bottom of the lakes. And methane is very optically clear. And so you could communicate from the bottom of this lake while your submarine is flying around to an orbiter that's heading overhead, that it wouldn't be like trying to communicate through water. It's very, very clear. You could fire a laser up through the methane lake and communicate. Think about a bottle of vodka, right? It's crazy. It's so weird and so interesting and so alien that anything that we have. And yet some of the conditions on Titan match what we might have had early on in the history of the solar system, of our own planet. So yeah, it's the world that I am most fascinated by is Titan. And then if I had to pick, the second one, it would be one of the ice giants, either Uranus or Neptune. We have to go back to those worlds and study them. Andrew Fish, my aunt took me to see 2001 Space Odyssey as a child, blew my mind. That's nothing remotely like in the 1960s. So I went and saw 2001 as a kid. I think I was like 7, 6. It freaked me out. I was so scared. I found it really unnerving. I had nightmares about it. It was a really scary movie. And I never watched it again. And it wasn't until about 6 years ago, maybe, I told my wife this, and she's like, well, let's watch it. I thought that's scary. because she had watched it and was fine. I'm like, yeah, we should watch it, right? Like I had this blank spot in my mind for 2001, and so we watched it, and it wasn't that scary, and you know, it was a great movie and really interesting. And now the trauma memory of my experience of watching 2001 has been replaced with my man, space is really cool memory, which is good. Yeah, it was like the it was all sort of scary in the spaceship and the robot murdering astronauts, and yeah, it was a scary movie to me. And like I'm sure we all have that movie, you know, that you watched when you were too little and it traumatized you, even though it was a great movie. And like whoever had you watch the movie did it with the best of intentions. Like, oh, you're gonna love this movie. You know, this movie is so great. And you watch it and you're like, I am horrified. And I can't sleep. And I am traumatized. There you go. Yeah. Tesla and Final Fantasy, RoboCop, Clark Holt, Aliens. Yeah, see, so Aliens for me was at that perfect age. I was 14 years old when we went and watched Aliens, and my buddy had watched Aliens. He's like, it's the best movie I've ever seen. I can't believe it. And so we went and watched it, and again, I was at the perfect age where it was action. I could handle the scary scenes, and it was like, I cannot believe I am watching this. It was like pure adrenaline just being jacked into my body. I've never had an emotional response to a movie the way that I did watching Aliens for the first time when I was 14 years old. And I'm sure, again, for all of you, have that movie that was the opposite of that you were at the perfect age and the perfect mental condition for it, that it stuck with you in a way that no movie ever has. It like literally changed the course of your psychology in a good way, right? And so it's always a dicey thing. And as a parent, you're like, oh, like, is now the time to show this movie to my kid? Because this movie was so great. Like, I remember I showed my kids Star Wars, and they're just like, this is dumb. This is boring. I don't like this movie. I'm like, I was exactly your age. I watched Star Wars and it blew my mind. I was 8 years old and I watched Star Wars and there was like sword fighting and there was spaceships and there was space battles. You're like, Dad, I could see space battles on anything. Let's play a space battle right now on my video game, on my Xbox. So it's context as well. So yeah, I think about sort of the movies. And it was later on with my son, especially, where he got into this age. I think he was like 16 years old or so. And he's like, okay, now show me good movies. I'm like, okay, we'll watch good movies. Hopefully it won't be too challenging. So we watched like Fight Club and we watched Pulp Fiction and, Shawshank Redemption and various movies that I thought were really good. And he had a great time, right? He was 16 years old, could totally handle it. You know, he didn't like Cabin in the Woods very much. It was a little scary to him. Didn't like war movies very much, but he liked other stuff quite a bit. And so now we still sort of will send back and forth, like, you know, tell me what to watch. What's good stuff? And both of us he's giving me a bunch of book recommendations. You know, now he's in his early 20s. It has a bunch of book recommendations for me to read. The whole Dungeon Crawler Carl came from my son. So, you know, now I'm passing it along to you. So anyway, media is a funny thing. You can potentially traumatize your child or potentially give them a fascination for the rest of their lives. It's a risk. All right. We've reached the end of this week's question show. Thank you, everyone who hung out with me. Thanks to the moderators who stuck around. I know Zapan dropped in for a second. Arjone is here moderating. Thank you for all of your help and assistance. We will be posting the new question show tomorrow, which is going to be from the last week's version, and then this one will come out in 2 weeks. I'm going to seriously think about how we do Patreon and how we do live streams, because it's time to make a stand. So I'm not sure what to do, but I'm going to think about this and take action very soon. Thank you, everybody. Always super fun. I really enjoy this. And we will see all of you next week. Remember, Pacific time next week.